The second and the last part of our video discussion will be all about the Ohm's Law. Ohm's Law is actually attributed to George Simon Ohm, who discovered the different relationships between current, resistance, and even the presence of voltage. These different terminologies that we are going to consider in this discussion might be somewhat familiar to every single one of you. Because in the case of Ohm's Law, this is already discussed to you during your Science 8 on your junior high school sciences. Now let's have a short recap of the different things that is included in this discussion. Now, whenever we are talking about Ohm's Law, once again, it involves different variables. Namely, we have current, which is represented by capital letter I, and the unit it is ampere, which is capital letter A. Then, followed by voltage, which is represented by capital letter V, and its unit is equivalent to volts, from Alessandro Volta, which is represented by small letter v, while some books are actually using or utilizing capital letter V as well. But in this case, for us to avoid confusion, let's utilize small letter v for the meantime. Once again, this is case-to-case basis when it comes to the utilization of the unit for volt. Other than current and voltage, there is also the concept of resistance. Just like what I have mentioned on the first video discussion that we have. Resistance, it is represented by capital letter R, and the unit for resistance, it is from George Simon Ohm, which is known as the ohms, okay, or ohm. It is represented by the Greek letter omega, or the horseshoe that is somewhat attributed to this particular kind of unit. Remember, in the case of Ohm's Law, we are going to consider here the relationship between current, voltage, and resistance. And once again, current is represented by capital letter I and the unit ampere, voltage capital letter V with the unit volt, and resistance with the capital letter R as its symbol and the ohm as its unit. Since we are talking about the relationship between current, voltage, and resistance, now let's utilize once again the triangulation of formula that I already introduced to every single one of you. In the triangulation of formula, we can actually determine here that current is equivalent to voltage over resistance. Or, we can actually get here the formula. If we want to know what is the current will be equivalent to voltage over resistance. Then, if we want to know what is the voltage, it is equivalent to IR, or current times resistance. And if we want to know what is the resistance, we are just going to utilize the formula voltage over current. Okay, so these are actually the different relationships of the different variables that is present in Ohm's Law. Remember the triangulation of formula, which is also mentioned on page number 6 of your module. Now, let's consider here some sample problem that we are going to solve. So this is just a guide on how you are going to answer these problems. The first problem that is present on page number 7 of your module, it is how much current is drawn by a lamp that has a resistance of 100 ohms when a voltage of 50 volts is impressed across it. Or whenever we're talking about impressed, it simply means that is present, okay, on that certain type of circuit. Now, let's identify the different parts of the problem solving that we are going to do. The first one, do not forget that we are always going to start with the G of Gresa, which is given. Now, for the given, what are the different things that is stated in the problem? First and foremost, we have here the resistance, which is equivalent to 100 ohms. After the resistance, we have voltage, which is equivalent to 50 volts. So apologies for the background noise. Then, After given, we have required. On required, as mentioned on the problem, we are looking for the current, which is represented by capital letter I. After current, let's proceed with equation. And for equation, we have here the presence of I is equivalent to voltage over resistance. Okay, so this is the formula that we are going to utilize. Then solve this problem. We have current is equivalent to the value of voltage. It is 50 volts over resistance, which is 100 ohms. Then for our answer, we have here the value which is equivalent to 0.5 amperes. Okay, so remember, whenever we're talking about the step-by-step guide in answering Ohm's law, we're going to consider once again the Gressa method and follow the triangulation of formula as set by our triangle earlier. Then, just like what we did on electric current, you can actually observe here that on page number 7, letter B and letter C, those problems are already answered and their Gressa is already stated on this page. Ohm's law introduced to us the concept of capital letter R or the resistance. Now, whenever we're talking about resistance, it is actually possessing here different types of materials that is responsible for showing how much resistance or how much the different current can be resisted by a wire or a circuit. And these materials that is present or shown on the video presentation here, specifically on this side, they are known as the different resistors. And you can actually observe here that the resistors are possessing different types of bands of different colors and at the same time in different numbers. You can actually observe on page number 8 of your module that every single one of these strips are actually possessing different types of meaning. If you're actually going to buy these resistors, they will actually vary in size. Some of them will be just like on this size, while some of them will be larger, while some of them will be thinner or thicker depending upon the manufacturing and the type of resistance that is present on every single resistors. Now, these resistors are actually possessing different types of capacity to resist the current flow. What is the significance of resistors? If you can still remember the discussion that we had earlier regarding alternating current, resistors are also needed by the different circuit to resist too much electron flow. From the name itself, they are actually being utilized to resist flow, resist current. And whenever they are resisting current, they are definitely some of the safety nets, or they are being used for the material not to overheat. There are actually different types of color bands that will actually indicate what is the value of the resistance that is present here. So let's simply start with this one. The very first color that we can observe here, it is color gray. Now, color gray is equivalent to first digit, which is number 8. We're getting the resistance, okay? Resistance of this resistor. Then, the second band, it is equivalent to red. Red, it is equivalent to number 2. Then, the next band, it is color brown. Brown, it is equivalent to 1. The next part, we can actually observe here that there is the presence of the fourth band. Okay? And the fourth band, it is now equivalent to color gold. Okay, so it means that our multiplier for this would be equivalent to 10 raised to negative 2 as mentioned on your module. And once again, do not worry, when it comes to the module that is provided, my source for this color resistor guide is actually what is being used also by engineering students, specifically electrical engineering students. So it will be equivalent to 821 times 10 raised to negative 2. Since there is no fifth and sixth band, this is now the value of the resistance that is present on the left resistor. If we are going to omit the scientific notation, it will be equivalent to the value of 8.21 ohms. That is the resistance of the left resistor. Okay, once again, Y8 because the color is gray, Y2 because the color is red, Y1 because the color is brown. Now, after the left resistor, let's now proceed to the right resistor. The first color that is present on the band, it is color brown. And brown, it signifies number 1. Then the next color, it is black, which is equivalent to 0. And the third color, it is red, which is equivalent to 2. Since there is no fifth and sixth band, we only have the fourth band. It is now equivalent to color gold, which possess the value of multiplier 10 raised to negative 2 ohms. Or, once again, if you're going to remove here the scientific notation, this value is equivalent to 1.02 ohms. So that is actually how simple you're going to get the resistance of the different resistors if you have one at home. Technically, these are just some of the different things that you're actually going to encounter when it comes to electricity. And if you want to answer other questions regarding resistance, there's also the practice makes permanent part on page number 9 of your module. And your answers for this practice makes permanent will also be included on the separate sheet of paper that you are going to submit for all the practice makes permanent part of our discussion for module 2. So if you have questions regarding this discussion, once again, please answer the Google form that will be provided on your Google Classroom for the second module, which is electricity. Then, we're going to have more discussions regarding electricity on module number 3, and we are considering here the concept of circuits.